This is a summary of all the polynomial methods that we've looked at in this chapter. There's nothing new in this section, but wanted to list it all in one place for you. Please remember that when we have these polynomials we've been talking about, once we can factor that polynomial into linear factors, then we are able to do a great deal with that. Please note that the solutions of the polynomial, so where the polynomial is equal to 0, are these constants, C1, C2, and so on up to Cn. Remember, in factored form, they're going to look like this. Don't confuse the factored form with the solutions. When these are real coefficients, then the x-intercepts, where it crosses the x-axis, have to be in this list. If that given c value appears multiple times, then it has the multiplicity of that value. And we can determine the behavior based on whether that multiplicity is even or odd. It's either going to cross the x-axis at that point, or it's going to stay on the same side. If it's a non-real zero, so it's not an intercept, but still a solution, then it has to occur in a pair. When these coefficients are all real, then we can use the ideas of the polynomial inequalities that we talked about before, where we test the point in the interval, see it makes sense, makes the statement true, and then everything within that solution, within that interval, is going to make the statement true. The rest of the things we discussed in this chapter are the techniques and the observations that we can use to create the big picture of these polynomials. Remember, we talked about the degree of the polynomial, and the sign of that coefficient can tell us whether the right hand is up, the right hand is down, whether they both go the same direction or not. Remember that we can find the y-intercept by plugging in 0 for x and solving for y. That helps us improve our graph. We can use long division to divide one polynomial by another, but we can also use synthetic division when we are dividing by a linear factor. And remember that that remainder is going to give us the value of the polynomial at c. So if this is a solution, if c is the solution, then this will equal 0. There will be no remainder. The rational zero theorem gives us that list of potential rational zeros. It's still a long list, but helps us narrow down where to start checking. And then we used Descartes' rule of signs to give us the idea of how many positive and negative real zeros the polynomial might have. We did not go into the upper and lower bound rule or the intermediate value theorem. Those are things that you'll get into if you continue on further in calculus. Remember, these are things to help us create a big picture, and then we can create those graphs and then get an idea of what's happening versus all the specifics.